Okay, we're now on to book 4, proposition 6, which says given a triangle ABC, prove that you can circumscribe a circle onto that triangle. So we're going to do this with 3 different triangles, which make up all of them, with an acute triangle, where the angles are all acute, a right triangle, let me draw the right sign right there, a right triangle, and an obtuse triangle. So we have that obtuse angle right there. So the way that we're going to do this, the construction will be the same and the proofs will be different for each triangle. So for the first type of construction, we're going to use proposition 10 to bisect AB and AC on each one. Bisect AB and AC. And we're going to call these point D and point E, respectively. Okay, so we'll bisect this one, point D, bisect this one, point E, bisect this one, point D, point E, point D, point E. Okay, next we're going to use proposition 11 to raise a perpendicular until they connect, and that will be the center point. So we're going to use proposition 11 from book 1, which allows us to raise a perpendicular from a point on a line. So we will be, so we're going to extend these lines to the point of intersection, and then that point of intersection we're going to call E for each and every one of them. Or we're going to call that point F on all of them. So you'll notice where on each of these, where that point is different. So if it's on an acute angle, the center point will lie inside. If it's on an obtuse angle, or if it's on a right angle, it'll lie on the line. And if it's obtuse, it'll lie outside of the line. So we are going to use, for that, we will write DF, and FE. Those points, those lines are dropped all at point F, which is the center. They're all raised. Next, we're gonna connect a bunch of lines. So we're gonna do this all in one. We're gonna connect AF in all of them, BF, which will connect in some of them, and CF, which will connect in some of them. So for this one, the only one that can connect is AF for the right triangle, because these are already connected. So for this one, you can connect all of them, so do that. This one, you can also connect all of them. Okay, so this one is just postulate 1, you're just connecting points. Nice and easy. Okay, step 4, we're gonna draw a circle using the center and one of the points. So you can use BF, AF, FC, whichever one. So I'm gonna make a circle ABC using distance AF and point F as a center. Okay, so these circles might be kind of rough, so don't judge. That's okay. Ooh. Okay, could be worse. All right, so this is postulate 3 that allows you to draw a circle using distance. Okay, so the first one that we're going to try to prove is this one. I'll mark it as a triangle 1, mark this one as triangle 2, this one as triangle 3. So whenever you're trying to prove that something is circumscribed, you want to try you want to prove that the circle hits at each point of the angle. So the first thing that we're going to do is try to work our ways toward the side angle side theorem. So I'm going to pull out this triangle, this ADF triangle, or this AFB triangle. I'll pull it out right here. F is the top. And it's split into two sides, so I'm pulling out two triangles actually. Okay, so we know that DB and DA are equal because they were bisected, and we did that in the first step, so we can write that down. We can write BD equals DA, and that is because of statement 1. And we know that DF is equal to DF, and that is because of common notion 4, which coincides, is equal. And we know that this is there's both right angles right here because we raised a perpendicular, and for perpendicular, it'll have right angles on both sides. So I'm just going to write that as angle ADF equals angle FDB. And that is because of statement 2, whenever we raise the perpendicular. So now we have side angle side here. So we proved this one, these two are equal. We proved these two are equal. We proved that these are both right angles, so they are equal. So now the rest is equal. But what we're concerned with is these. So AF and FB are equal due to book 1, proposition 4, side angle side. So AF equals FB. So that's because of book 1, proposition 4. And we can do the same thing on this triangle right here, AFC. We could do the exact same steps, proving that this is equal, right angles. So AF is equal to FC. So with common notion 1, we know that AF, FB, and FC are all equal to each other. So I'll write that, AF equals FB equals FC. And you could put whatever you want here, but I'm going to go with common notion 1. So now we know that coming from a point and a radius, because it's in a circle and we have 3 things coming from the same point as equal, so that makes F is the radius, which we already use, F as the radius, and we have F coming from the circle, and the circle is hitting each point of the angle in the triangle. So that means that this circle has been circumscribed. So I will just write triangle ABC, and I'll put 1 in front of it, has been circumscribed. Nice. Okay, and reason for that is the definition of circumscribed. Let me find that very quickly. Which is book 4, definition 6. So 1, 2, 3, 4, 6, definition. Sorry. Okay, next one we're going to do is the right triangle, which is even easier. So for this one, we do the exact same thing as the last one. You'd prove that BD is equal to DA, and then you'd prove that these are both right angles. DF is equal to DF. So you can similarly say that BF is equal to FA, and then you can do the same thing on this side with FC and FA. So you effectively will do the exact same thing. So I'm just going to say similarly for this, because you do the same steps. Similarly, BF equals FA equals FC. And reason for that is just above, because you would use the exact same steps as you did in that one to prove this one. So we're just going to say that we're going to call that one 2. So 2, triangle ABC, has been circumscribed. And we know that for the same thing, book 4, definition 6, which describes, as we can see here, BF, FA, and FC. The center point going out, the radius is hitting all angles of the point, so we know it's circumscribed. All right, last thing we're going to do is this one is with an obtuse angle. So we're going to use the same steps. We're going to pull out these triangles right here, BFA and AFC. So BFA is going to be the big triangle. We'll just use this again. We can say the same thing, that BD equals BA, and then BF, and then DF equals DF. This is the same thing. It's cut, so it's raised a perpendicular, so we know that these are both perpendicular, which makes these both right angles. So that means BF equals FA, FA equals FC. The same thing, for the same reason, you would use the same thing. And so now we know for this triangle that from the center point, it is hitting all of the angles. So we know that this triangle 3 has been circumscribed. 3, triangle A, B, C, circumscribed. For the same reason, book 4, definition 6. All right, so we have now proved that for each of these, we've circumscribed a circle around it, hitting at each point on the angle. So, boom, we are done, and that is QEF.